Hi, this is Robert from Part Fusion Electronics. In April of last year I made two videos where I was experimenting with supercapacitors. I was going to look to try and use a small supercapacitor like this as the power source for a piece of jewellery. And I had made up a small boost converter circuit based on the ME2188, a very cheap boost converter that I was hoping to use to get as much of the power out of the supercapacitor as possible. I was travelling at the time and I only had access to very simple tools and test equipment, and so I'd made up a circuit like this. I've lost the original circuit. I've recreated the circuit here. So this is the boost converter here, and then there's a small inductor. When I connected up the supercapacitor on the input side here, I wasn't getting a stable voltage on the output. I didn't have access to suitable tools, so I wasn't able to really diagnose the problem in much detail. So now that I was home, I was able to kind of do some more experimentation, and the reason I was having issues before was that the inductor here wasn't beefy enough for the circuit. This is a 22 microhenry inductor. When I looked up the datasheet, actually it turned out to be that it was a ferrite bead, so it wasn't really suitable at all. So looking through my components, I was able to find this other 22 microhenry component. So this was an 0603 package, and this is a 1210, this package here. So I think it's a bit easier to see the differences in size between these two pieces of tape. So this is the basic circuit. The piece on this board is in this dashed box. So in the center we have our boost converter. On the input side there's our inductor. There's some output capacitors, and there's also an input capacitor. And then on the input, so this is my 0.33 farad supercapacitor. I have a Schottky diode and my 5-volt supply and a pull-down resistor. This is just for cleaner triggering on my oscilloscope. And then in the output, there's a 200 ohm resistor and an LED. Here I've got my circuit mounted onto a breadboard. I'm going to connect my input voltage here. I then have my resistor and Schottky diode here that help for the triggering on the oscilloscope. Then I have my supercapacitor, which is here. I'm going to have an oscilloscope probe on the input, which is going to go here. I then have an input capacitor. I've got my inductor. Then the boost converter is here. I've got my 3 output capacitors that are kind of here. So I'm going to have an oscilloscope probe on this point in the circuit, which is here. And then I've got my resistor and my LED. So the output current on the LED is approximately 7.5 milliamps. So on the right hand side I have my breadboard connected up to the oscilloscope and getting power from a 5-volt supply. And on the left is the screen of my oscilloscope, a Rigol DS1102E. When I disconnect the power supply, we can see the oscilloscope triggering. So the yellow trace is my input point, which is here on the circuit. And that starts off at about 4.3 volts, and then it starts to dip down. And once it goes below 3.3, the boost converter starts to kick in, and it starts to, so it does everything it can, pulling power from the supercapacitor to bring the voltage up to the 3.3 output voltage. So the output voltage here, and that's the blue trace on the oscilloscope. So the LED keeps lighting even after the boost converter stops boosting up to the 3.3 volts. So just for comparison, here's another version of the circuit. This top one has the boost converter, and this bottom one is just a supercapacitor on its own. The blue line will represent the output from the boost converter, and the yellow line will just be basically the output of the supercapacitor. I've also adjusted the time base on the oscilloscope so that we can see more of the trace and what happens after the boost converter has depleted most of the power on the supercapacitor. The boost converter circuit and this supercapacitor are able to last about 40 seconds. And now the voltage of the boost converter is lower than the voltage of the normal supercapacitor. And now at this point, the boost converter is kind of taken most, if not all, of the power out of the supercapacitor, and it's kind of turning off, and then as the supercapacitor kind of slightly regenerates, it's turning on again. On and off, on and off. The output LED is also a little dimmer. Well, that's hard to tell with this lighting. So the supercapacitors, they come in different sizes. So I have like a 4 farad, 1 farad. I'm using here a 0.33 farad. I could potentially put 2 in parallel, and that would give me potentially 80 seconds. But I could also look to use a much lower output current. So this was about 7 milliamps. But it's hard to know if using a boost converter is much use for some of the projects I have in mind. I'll have to think about this a little bit more and maybe come back to it again. Okay, thank you. Bye bye.